With now talking about trigonometric functions of any angle, we have 4 definitions of trigonometric functions. And you might think that that's a lot. You might have to say, okay, what is the difference between them? How do I distinguish them? And really, to a mathematician, we see them all the same. It's just you have to tweak them a little bit depending on how the context is presented. Okay, so this video is going to kind of hopefully connect the 4 definitions for you. When we first saw trigonometric functions, we saw them introduced using the unit circle. Okay, so if you remember, we had, okay, I'm going to attempt to draw a circle. Hey, that's actually pretty good. When we saw that, we talked about an angle in standard position, but we actually defined them by talking about this point P of xy. And to get to P, we traced the arc length, right? So we had an arc length definition. Maybe this one you want to remember this is arc length instead, arc length definition. But we traced the edge of the unit circle from the point 1, 0 up to P of xy, and then said, okay, we could talk about sine of t being something there, okay? Being how far we traced along there in the y direction, right? And then later on, we came back and said, oh, no, right? We don't need to talk about arc length. We can talk about a central angle instead. So same idea here. We have the unit circle. We're still looking at this point P of xy. And instead of looking at the arc length, right, I can imagine that if I am looking at this arc length t along here, right, I can say, okay, well, I can create a central angle here that would be in standard position and have a terminal side that passes through P of xy. And we said this is fine because when we look at the unit circle, we said that, you know, our radius is 1. So then when we have the arc length formula, right, r is just 1, so t is equal to theta. So our definitions all carry forward because we have the same, the arc length is the same as the central angle, okay? So this one kind of fed into this one, and it's really vice versa, okay? We can move between those definitions. Later on, we then introduced the idea of a right triangle. And so to get there, what we ended up doing is saying, okay, well, imagine we dropped an altitude. And with this altitude dropped, I'll kind of redraw this picture down here. So we have, you know, our P of xy as the point here, P of xy, and then we drop that altitude. We still have our central angle theta, and then we get the horizontal distance, or that first leg of this right triangle as x, and this second leg of the right triangle being y, and then we can talk about the hypotenuse via the Pythagorean theorem because we now have a right triangle, okay? So, and then we kind of said, well, previously, like we talked about sine of theta, for instance, as y over 1, right? But now, in terms of our context, right, 1 isn't necessarily 1 anymore, but it's x squared plus y squared. We are on the unit circle, so in actuality, this hypotenuse would end up being 1. But nevertheless, it gave us a way to adapt our notation to instances where we maybe aren't on the unit circle. So we generalized this to say this is the opposite side over the hypotenuse, right? And then we similarly adapted the other definitions of the trig functions, cosine, tangent, etc. Okay, so in a sense, we took our central angle definition and went into right triangles, okay? And then to get to our last idea, right, and we looked at these triangles and said, okay, well, we know that this is x, this is y, this is 1, right? And like I said, define the trigonometric functions appropriately. Now, we're allowing for the case where maybe we're not on the unit circle. So what we can do is look at right triangles that are similar to this small one. And when I say similar, that usually means, or that means that all the sides are a multiple of what they were previously. Okay, so we'd have y times r for the vertical, x times r for the horizontal, and now r for the hypotenuse. Okay, so we just scale them up, we make them bigger. Okay, and so what we see in the coordinate plane, okay, we now have this point P, or I guess I don't know if we necessarily have P, but we have something that is out a little bit further. So let's call this Rx. And then we have something that's up further, call that Ry, R times Y rather. And then the diagonal distance still as R. This would still be theta. Okay, so we just have something that's bigger, right? And we would say that if we needed to just verify, for instance, if we needed to verify that this is indeed R, we would still do the Pythagorean theorem. So R would equal the square root of R squared x squared plus, let me rewrite that, Rx squared plus Ry squared. And then carrying the algebra through, we'd have square root, we'd have r squared if we factored it out, x squared plus y squared. Okay, we can pull the r out front. Square root of a square is just positive r, and then we'd have square root of x squared plus y squared, which we knew to be 1 previously on the unit circle, so that's how it kind of simplifies. It just goes to 1. But more generally, we define r, and perhaps the canceling out doesn't really make sense, but previously remember that we defined square root of x squared plus y squared to be 1, so it actually just reduces to just r. Okay, so just a little proof there. If it doesn't make sense to you, don't worry about it. But the main idea is that in the any angle definition, all we do is scale up the right triangle definition. So for instance, if we were to still look at, our sine function, okay, in this context, sine, and I should actually label this would be our angle theta, that's our acute angle that we're working with. But if we look at sine theta now, what we end up with would be y times r over r, times 1 technically, and we could reduce, and we just get y over 1. Same exact thing as what we had before, okay? So all these definitions lead to one another. Okay, if we wanted to go from the any angle definition back to unit circle or central angle, all we have to do is scale down, so divide by r, and we get the same thing. So that's why when we're talking about any angle definition, usually, okay, this is the not scaled version, but normally if we wanted to scale down, we would just take this triangle, the one that's given to us, and divide it by r. So that's why our definitions become y over r, because this y is already scaled and we need to shrink it so that it's on the unit circle. Okay, so nevertheless, this video, the intent was to help you understand the connection between the definitions and really understand that when mathematicians talk about trigonometric functions, yeah, there are specific types of definitions, but we generally see them very closely related to one another.